All right, so we're going to be lesson 7-2, chapter 7, second lesson, and we're going to be talking about dividing monomials rules. And today's date is the 11th. So I'm going to give you an example, and then hopefully you guys can come up with a rule that we can use so that we can save time. Because like we were talking about the other day, the length of time spent on 9 questions, which would expand to the total length of time allowed for 50 questions on the placement test, we've got to be able to buy time with these types of problems and save up our minutes for the harder problems. Okay, so that's how taking a test needs to work. Yes?
So the placement test, is that a bit of everything?
Placement test covers the entire year. Yeah. Michael?
Brad don't have to take it, right?
No, you have to take it because it's a grade for our class.
What?
Yes, it's your final.
What?
It is your final.
It's a grade and a placement test.
Yes.
So what if we do really bad?
Then it might hurt your grade. Yes. Okay, no, you have to take this placement test, which is based on what we're teaching, which is based on what you're expected to learn. So that's how it works. So I don't know what would make you guys think that this test was not counting. This has been a final for this course for years. Yeah. Unless you want me to give you a second final, I can do that too. But I think this should be taking care of that in one shot. So let's get back to the matter at hand. So let's say that you have this problem. 2 to the 7th divided by 2 squared. So what I'm going to do is expand out what 2 to the 7th means. 2 times 2 times 2 times 2 times 2 times 2 times 2. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to divide it by what 2 squared means, which is 2 times 2. And then I look for anything that I can cancel out. So for example, what's 2 divided by 2? 1. And what's 2 divided by 2? 1. So what I'm left with is 1 times 1 times 2 times 2 times 2 times 2 times 2. And so what I could say is that I end up with an answer of 2 to the 5th power. Now, I can expand that out. I can make it 32. But in order to get to 32, I got to see what I have first. So let's look just exponentially. What does it look like happened from the original problem to get to the answer that was with exponents? Jackie? Okay. So here's what Jackie said that was very important. Subtract the 2 from the 7. So the rule for dividing monomials with the same base you will subtract the exponents. Now, you guys are not in 2nd grade learning how to do subtraction for the first time, as my daughter is, who often likes to take the smaller number from the bigger number, regardless of where that bigger number is. And so she ends up getting the wrong answer because sometimes she's trying to do 1 take away 3, and she says the answer is 2. But you know you can't do 1 take away 3. Okay, hold on. Listen to it. You can't do 1 take away 3 in 2nd grade. They don't know the concept of negative numbers. Plus, this is a 3-digit number take away a 3-digit number. You can't do that with 3-digit numbers or 2-digit numbers. You have to be able to rename in order to do the subtraction. For us, you need to make sure that you're going to subtract the exponents, and I'm going to make it bolder. Numerator minus denominator. Top take away bottom. Oops. Now, You might say, well, wait a second, that's going to give us potentially negatives. That's true. And we'll talk about exponents that are negative and exponents that are 0 on Monday when we come back. So today we're just going to deal with this idea of when dividing monomials with the same base, we're going to subtract the exponents, and that means numerator take away denominator, always in that order. So if we have the a to the mth power divided by a to the nth power, this rule says a to the m take away n power. Numerator take away denominator. Always, always, always in that order. Do not switch the numbers. Okay, because signs do have an importance, and we'll talk again more about negatives on Monday. Brandon, you had a question? Okay, I thought I saw your hand up. All right, so I'm going to give you directions, and we'll do a couple of examples of this, and then we have one more component we're going to add in here. And I want to point out something that they mention in the directions, and why do they have to mention that? They're going to ask you to simplify, and then it's going to say assume that no denominator equals 0. Okay. And you're going to see a problem like g cubed h to the 5th divided by gh squared. Okay? This is when it's really important for you to remember, if you don't see an exponent, what is the exponent? 1. So there's a 1 on that first g. Now, why do they add that second piece of information, assume that no denominator equals 0? Brandon?
The problem would make sense.
Why wouldn't it make sense?
Because 0 can be in the denominator.
That's right, because what does 0 in the denominator actually tell you? Okay, it will be undefined because mathematically, what are you doing? Dividing by 0, and that's the one thing in math you can't do. So they put that in there because those are variables in the denominator. We don't know what those actual variables equal, so we're going to assume that none of them are 0, because if they were 0, then we'd be dividing by 0 and this problem would be impossible. Okay, so using our rule, what we're going to do is take each of the variables, and we're going to numerator take away denominator on the exponent. So on the g, it was 3 take away 1. On the h's, it's going to be 5 take away 2. So the result is going to be g squared h cubed. And that's it. Okay? Let's do another one. Yep. K m to the 7th, m to the 10th, p over k to the 5th, m cubed, p. So again, first thing I would probably do is any variable that doesn't have an exponent, I would just put in its exponent, of 1. And then I'd start my process. So I have k, numerator, take away denominator, so 7 take away 5 on the exponents. M, it would be numerator, take away denominator, so 10 take away 3. P, numerator, take away denominator, 1 take away 1. And then the answer would be k squared, m to the 7th, and then I get this guy. Now, we're kind of previewing something that's going to show up on Monday. What do I get when I divide something by itself? So when I divide p by p, I get 1. So actually, this also equals 1. When you get an exponent of 0, so again, this is kind of a preview of what's showing up, we end up eliminating that variable as being part of the answer because it canceled out. So your final answer is just k squared m to the 7th. I'm pretty sure I excluded any problems like that from your homework. Okay, so let's talk about a little bit of a complication. What if, so this is now going to be dealing with a scenario, what if you're asked to deal with this problem And we kind of dealt with this with monomials that did not have fractions. We did kind of talk about it, I think, a couple times. When you're raising a quotient, so anytime there's division involved, it's called a quotient, to a power, who gets the power? Both of them, okay? So when you have a quotient being raised to a power, they all get raised to that power, okay? And 3 cubed is 3 times 3 is 9, times 3 is 27. 4 cubed is 4 times 4 is 16, times 4 is 64. And we would get this answer. Now, would I, let me see if I'll put it this way. If my original fraction is simplified, so there's no common factors, and I raise it to a power, do I need to check my answer to see if it will have any common factors?
No, because
Yeah, because we just have a repeated fraction that doesn't have common factors. So we will not get common factors in that product, because that's what we're going to end up having if the original fraction was not simplified. Question, Jack? Or okay, yawning with one arm up. Okay, got it. Okay. So basically, we have power of a quotient. Let's say when raising a quotient to a power, raise the numerator and the denominator to that power. Now, this could incorporate, what if that original guy had an exponent and now I'm raising it to a power? So now we're going to use the power to a power rule in addition to this quotient rule. So basically what it's saying is if I have A over B and I want to raise that fraction, that quotient to a power, I'm going to raise the numerator to that power of m, and I'm going to raise that denominator to the power of m. Okay? So again, let's do a couple problems that are going to not be as simple as let's just cube everything. So let me hold on a second. So I'm going to go back to examples, and again, the directions are going to be the same thing. Simplify. And these are going to be a little bit different. We're going to, again, assume, let's see, how did they say that again? Assume that no denominator equals 0. I'm going to abbreviate denominator to denom. So let's see, we're example 3, right? So I'll do an easy one, and then I'll do, well, no, I'm just going to do harder ones. We have the monomial 3x to the 4th over 4, and I want to cube that. So according to what our rule says, it says you're going to cube the 3, you're going to cube the x to the 4th, so there's that power to the power. You're going to cube the 4. So I'm using the notion of power to a power, but remembering that power to a quotient, everybody gets treated the same. So that's my brain step, and then I do my math. So 3 cubed is 27. 4 times 3 gives me x to the 12th. 4 cubed equals 64. Done. That would be that's why I boxed it up. That is the answer. Now, this is a good question to ask. I got 2y squared divided by 3z cubed, and I want to square that. Now, can I call that a monomial? Why not? Because you can't divide by a variable. So that's when I call number 4 a term that I want to square. Okay, I can't call them a monomial because one of the rules said you may not have a variable in the denominator and call it a monomial. Okay? All right, so again, brain step. I'm going to square the 2. I'm going to square the y squared, so multiply my exponents. I'm going to square my 3, and I'm going to square my z cubed. And then I just do out the math. So 2 squared is 4, 2 times 2 is 4, 3 squared is 9, and 3 times 2 is 6. So my answer is 4y to the 4th over 9z to the 6th, or 4y to the 4th divided by 9z to the 6th.
Do you have to show the blind stuff one?
What do we talk about brain steps?
No, you don't.
Brain steps are in your brain. We put them on our paper in our notes, so you're seeing exactly what's happening. But your requirement is top, black, black. You're expected to write the original problem. You're expected to write the final answer. That's as simple as these particular problems are going to be. Okay? They'll get more complicated. Don't worry. We'll amp it up a little bit. All right, that's all I got for you. So,